Alright, I think we're back again. Starting a bit late, and I don't think this is going to be a really long stream, but I had a few more tweaks to this design that I really wanted to try, and wanted to do those on camera. So here we are. Welcome back. Let's put a fresh card in the camera machine, the photo making device. Yeah, if you're into frequent streaming, the last day or so has been your lucky time period. So I'm going to give just like a really abridged recap of this. This is a small standalone project that I'm doing just as a relatively quick thing to see if I can make a robot that is easy for people to build at home or in the classroom. And it's kind of an exploration of minimalist robotics and art based on random physical motion. But whereas you might have seen a lot of robots that just like randomly skitter around with brushes and produce only balls of hair, for my robot, this is actually an indication that it isn't really working right. This is like a piece of scratch output paper. And in my case, what I'm going for is actually stuff that looks a little bit more like that, or even if we're luckier, you know, kind of a little bit more like that. Stuff where we actually have an intentional pattern that we're trying to draw by controlling the robot and kind of blending its natural random motion with some algorithmic control and feedback. So I personally think this project is interesting for a few reasons, but I think maybe the biggest one is just kind of my thing about using closed loop control to show people how much kind of nuance you can get in the control loop itself and the results you can produce with that, rather than just having to have really high fidelity actuators. So yeah, and we've made several variants of this so far. I should really be recording this. Several variations. The first version, which is the one that I've had the most success with so far, was this 3D printed bot. This has some nice characteristics. It has 3 brushes that are right underneath the vibrating weights, and then the rest of the surface is a little bit compliant because it's all made of NinjaFlex, which does a reasonably good job, it turns out, of transferring energy to the vibrating locomotion brushes that pull the robot one way or another. While also kind of isolating them from each other. It seems to do that all right. The pen is somewhat adjustable because you can change kind of how far down it is in that hole. The whole thing, though, is not actually that adjustable, which is its really main downfall. So it's been all right, but you can't adjust it except really for positioning the nib. And then this wire leash is silicone wire, which is flexible but kind of heavy, and it pulls the bot around kind of significantly. Did a couple other versions. Did a couple of versions based on just little paperclip stick legs instead of the brushes. And I've kind of given up on these because the single point contact is just really, really fiddly, because the particulars of the surface geometry right at that single interface can just change so much about the way the bot moves. And I mean, basically what we're doing with a brush is having a lot of those interfaces that all kind of aggregate together into some motion that maybe we can have some more control over. So that's what led to the current design, where I'm using off-the-shelf brushes that we're modifying. And turns out that, well, toothbrush heads are pretty good as a small brush that you can modify for stuff like this. So, oh, Tuco, honey. Do you want to play Bolt, honey? Oh, just threw the bolt somewhere he couldn't hear it. That's going to be tricky. I should get the cat camera started. Me too. I was having trouble with startup. Nice. Donovan says morning from South Africa. Always nice to hear from other time zones. Cool. And Andrew says, hello, I'm watching this in the background as I get mad about C compilers. Well, I hope you don't stay too mad, but I'm glad, I guess. I hope I'm helping. Oh, there he is. Okay, back to the usual. His stylish cat butt. Ha, nice. Paul Moffat says minimalist robotics. I love that turn of phrase. That's, yeah. I mean, that's certainly been an interest of mine for a while. I haven't really found time to do very much of it, unfortunately, but if you've heard of BEAM robotics, it's an acronym for, what is it, biology, something or other, aesthetics and mechanics, energy, I think. Anyway, it's like an acronym of like its core principles or something, but basically it's a philosophy for building simple robots that have emergent behaviors rather than programmed in behaviors. And so that's really in keeping with what I like. And so I like that philosophy, but I haven't really spent much time like just building robots out of like simple analog circuits and stuff. And so this, like incorporating a Raspberry Pi, I don't know if you could call it Beam Robotics then, but the actual moving part of it is pretty simple, and I'm trying to use, for sure, kind of biology-inspired approaches where I use, oh no, I'm gonna have to fix this. Approaches where I use like feedback loops instead of precision manufacturing. I am going to have to actually put this ball bearing back into place, pardon me. Oh, I almost dropped that tool in a bad place. Alright, let's tighten that up and get this camera off there for a sec. Sorry, let's switch to the cat cam while I'm doing this maybe. Or maybe the desk cam so like you can watch me drop my camera. Oh, that's a good question. Thomas is wondering how my notification bot works. If you're curious about any of that streaming infrastructure, if you go to github.com/scanlime/broadcasting, there's basically like all the scripts and software and stuff I use for this. But yeah, basically there's an intermediary between the streaming computer and the outside world, like Twitch and YouTube. And it's a server running Nginx, the web server. And so that thing, it does a variety of things. It takes screenshots, it transcodes video, it calls these Python scripts, which then generate those descriptions. I don't currently have a great system for metadata, actually, so like if they seem like they know what they're doing, that's just by accident. It's like randomly generated right now. It's like Mad Libs, basically. So like it's relevant in terms of just like generalities about what I tend to do on these streams, but I don't tend to edit it before I run a particular stream. The only metadata I currently keep, like for myself when I'm recording video, there's like project and date basically is all. And then when I'm streaming, right before I start the stream, I set up a title. And I don't actually have a good way of doing that right now. I'm just manually editing it in the dashboard on both Twitch and YouTube. So that's actually something I could use better infrastructure for. Okay, so, oh geez, I don't know how much of that's visible. There's a ball bearing right here. It's like a cam plate with 3 ball bearings in it. Oh shit. I dropped one of the lower balls. Tuco is very interested in it. I think I saw where it went. Yeah, I hear you, boy. Okay, that goes down here. There's a lower ball bearing also, which I was trying to hold in place with my finger. This thing is kind of annoying. I wiggle that up. Yeah, Tuke, I see that you have a bolt. I should really figure out what kind of ball bearings go in this so I can replace them when I inevitably need more. Okay, I think the way this has to work is I start it by giving it a few turns up here, because otherwise that lower bearing is going to come loose. And then I drop it down, and then carefully, without dropping any of the bearings that have just popped out the bottom. You know that fruit dispenser in Back to the Future 2? It's basically done that with ball bearings. But I can't really show you because of the camera angle. Okay, and then, gosh. I think this is the thing that I hurt my finger on yesterday too, which makes me really just want to ditch this and get one for my main camera that has a friction lock with like a turny screw thing instead of this lever. This lever is nice when it works, but it's the source of all sorts of problems. I've almost always got grease in my hands after I work on this thing too. Of course, now that I have the camera down here, I'm noticing my lens could use some cleaning. There's one of these microfiber cloths. Okay. All right. Well, hopefully I have taken care of things. Put the battery back in the camera. Oh yeah, and so this is just a regular DSLR. This is a Canon Rebel T5i, which I think also goes by some other name that I'm forgetting. They were marketing these under multiple model numbers for some reason. I didn't buy this for what I'm using it for now. It's not like designed as a video camera. It just happens to have 1080p video. And it's like the best video capable camera that I have in terms of just like lens and optical quality and focus and all that. Although, you know, it's you know, like I actually still do use like video from my iPhone a lot in producing stuff. Like it's, for certain things, like I have to have DSLR video, but a lot less than used to be the case. Okay, let's try. Okay, where were we before my camera was starting to self-destruct? Okay, different versions of this. Anyway, yeah, anyway, earlier today we built most of this robot. So we were starting from this point where I had one of these feet assembled, and so I built a few more feet. Anyway, I learned a few things from this one too. There are some things here that worked really well. I really like the way the paper tube worked in this assembly. So the whole thing in the middle is based on this single paper tube, which is rolled really tight, like as much as I could in the middle, and then let relax. And the cool thing about that is that it acts as a bit of a spring that helps hold the pen in there. So this kind of, you have to like turn this counterclockwise to release that spring. But then after it's in there, this kind of helps grip the pen a little bit, which is kind of cool. I might have made it a little bit small this time, but the general idea is great. And that then does a good job of actually, well, the brushes right now are at weird angles, but the pen holder is working quite well. Then, it was also pretty easy to put the coil on this one, and cutting the end and folding it up, and then using that as an end stop for winding the coil, that worked pretty well. The sticky tape around everything, including the joints up here. That all worked pretty well, and the magnet wire. I think all that was good. So I'm basically happy with the wiring, the tube, and the motors, and like the connections and all that. So that said, the toothbrush part of this is kind of a mixed bag. I originally pulled the bristles out in this pattern so that the brushes, as they lay flat on the table, would end up kind of, so they would end up pulling the robot that direction. So for example, if this was sitting on the table, I originally wanted this joint to be kind of on the outer edge of the robot to put the vibe motor kind of near the furthest point, like the extremity. And then the idea there was that that would kind of hop along and pull it. And originally, I'm just going to do this now. I'm just going to bend this. So originally I had it done more like this, where if you look straight at the center of the robot, it was more like this angle. This is how I originally designed this to work. So you would have that there, and I'm just going to do that to all these. Anyway, there's stuff that I like about this. One thing that's just really not good about this is the whole robot is just way too big with this setup. It means that it's, like, you can really only use about the middle half of the tablet, if that, because otherwise it's just going to fall off. So you still have to draw fairly small things. So that's not great. That's why I was experimenting with designs that folded the brushes in against the side here. So then, the other thing is I was thinking about different linkages. So one reason that I was caring about the brush being flat against the page like this, so like if this is attached to a rigid center, then you can angle all the brushes separately as long as the whole thing balances somehow. But I was imagining that maybe each brush would actually sit separately, and then it would have almost like a little like wagon or like a train linkage, like a chain like this. So it would have like a pin that could pull the robot, but then like this could like vibrate, especially like up and down and around. But then as it moves in a particular direction, it would pull the center, but still move freely. So I was imagining having a linkage like that. I still might try a design like that. I haven't tried that so far, mostly because I just think it would be, I just can't imagine a way that that would actually work out so super well. I keep like putting it together in my head and hating the results. The whole thing would be really floppy and hard to keep from damaging itself. And like the reason those joints are good is it helps you isolate the different pieces from each other really well. But I don't know, you'd still need this to basically have its own little foot that it would sit on just to keep the coil on the page. I don't know, I might try that, but I don't really like that idea super much. Anyway, one of the problems with this current design is, like, so besides it just being too wide, as I mentioned, it, the vibration is not very well isolated between the legs. So I can feel, like if I just feel this or look at how much it's vibrating, you can definitely feel that the vibration is stronger at the foot that actually has the motor on it, but it transmits a lot more vibration than I like to the other feet, and that just generally makes it really hard to tune because all of the feet affect each other and they can all kind of unbalance each other very easily. So that's been more annoying than I'd like. But I mitigated that somewhat by just taking the paper clip and like kind of coiling it as much as I could into like a space filling curve. And if I were building one of these, you know, from scratch without this thing already being assembled, I would probably like coil that around something to give it as much isolation as I can. So yeah, I think that would help. But then so then this evening when I was thinking about this after the stream today, I thought of an even better strategy. Like, also I was thinking, like, well, what materials do we have that will absorb the vibration? Part of what was actually really good about this design is that each of the paper clips are separate, and any vibration that goes through this actually first ends up going through this tape joint and then the paper. And so I think here a lot of what's actually going on is just that the vibrations end up just kind of fatiguing the tape stickiness over time, which is not amazing, but that they still don't transmit super well. which is good. But then I was thinking like, well, what if I just use the paper clips as paper clips and then clip them like to the top of a larger tube like this? So now the design is starting to look like maybe, so imagine this tube. I could even maybe probably reuse the same tube without remaking it. So I take this robot apart, I take the tube out of here, take this plastic off, save the vibe motors, but discard the toothbrushes and paper clips from this one probably, or use them for another project. And then I'm thinking what I want to do is pick different toothbrush heads. That's why I'm saying I want to take those apart. Because here I was planning on having them stay flat on the page and provide some directionality. But I think, especially if I'm taking these and relocating them to the, like these kind of snug positions where the flat edges are kind of the triangles, it's almost like kind of a delta configuration versus a Y configuration, if you're familiar with that. Just the two shapes. So moving these brush heads kind of closer here so they form the triangle itself. I wouldn't even necessarily need this structure here because that just came from the twisted together paper clips. So I used the heads themselves. Oh, Took, don't do that again. So we use the same brush heads in a triangle, but then get the directionality by just picking a brush that's mostly straight up and down and then angling them inward. And I think that's going to work better. More isolation between the brushes, and then I think what I can do is take a paper clip, only partially unfold it so it can still attach to the paper tube, but like just unfold one leg of it, and then take that and use pliers to bend a very small loop, and then just heat that loop up and dig it into the a toothbrush head. So, oh, Tuco. Can you guys hear the gimbal from over there? It's kind of loud here. Yeah, so Joel is suggesting using rubber as the pin in my hinge, in that, like, kind of, I assume, like, the kind of, like, pin, like, railroad car kind of configuration or whatever. Yeah, that's a good idea. I guess the main thing I'm imagining there is that I just don't know how to integrate that into the overall structure so that it's sturdy and easy to just build. Like I can imagine in this design, you could have like a separate rubber piece here, and so one thing I was thinking about doing for the linkage was to just mold in a piece of string, or like nylon string or something. And you could just take a little piece of that and just like include it in the shape block as you're working it in there, and that would provide a really loose joint. And you could do the same thing with like a piece of rubber, like a little rubber strip or rubber cord or something. I think I was just more overall concerned with the lack of rigidity there, and how I wasn't sure if that would really interface well with the tube here. I think what I've got in mind would be a little bit like this, except the paper clip's attached to the paper instead of to the tape. And then this sticks into toothbrush heads. I think that's basically it. Yeah, and then Andrew is suggesting using hot glue as a damper. Yeah, for sure. That thought definitely occurred to me as well. It's mostly just that. It's not just like I can have a single small area that is, like it's all about the joints between these surfaces. It's like, well, yeah, I can use hot glue, but like, what am I going to do? Am I going to hot glue the toothbrush head directly to the body? Well, that's actually not enough damping, probably. That's not very much. Not as much as I have now, probably, because this flexes quite a bit. If I, for example, what if I hot glued some portion of these paper clips together and then cut in the middle, and then let the hot glue keep the structure? That's kind of more like what I was thinking might work, but then the joints between the paper clip and the hot glue are now by far the weak point, and that's just going to come apart, I think. So That's why I was just kind of going down different paths. Like, I started down that path, but I couldn't really find a whole solution that seemed to work. Max Radio Repair says to build it all out of hot glue, like using a silicone mat as a mold. Yeah, maybe. That's like closer to what I had in the first revision here with the 3D print. I think if I was going that route, it would be tempting to go back to modeling it in CAD and then using NinjaFlex for most of it, and then like sticking paper clips in the edges of a NinjaFlex print as an armature that you can adjust. Yeah, something like that. Anyway, I think maybe the next step is to partially disassemble this. Stabbing the paper clips into a sponge. That's an interesting idea. Huh. So the other thing that is necessary, like when we're talking about materials, like this isn't like a green field necessarily. We aren't designing this completely from scratch, because this also has to interface with whatever's holding the pen. And so I'm actually pretty happy with this pen holding tube. We certainly could do something else to hold the pen, which was probably what we'd end up with if we're like making the whole thing 3D printed. But absent that, I do actually kind of like that, and so it'd be good to think about how to make that attached to something like this tube. So let me just try the paper clip on this tube first, actually. I'm curious about that. So I'd probably want something like that, and then the toothbrush part would be like, fold that down and out, and then this would be in there, and then maybe some tape over it. Is there still enough room for the pen in there, or do I need a bigger tube to start with? That might have, oh, it's kind of there. I don't know if I'm going to fit 3 of those in there, though. I might need a bigger pen to start, or a bigger tube to start with. Well, I don't really have to put the paperclip in the inside of the tube to use it as a damper the way I'm thinking. I could do it basically the same way I did this second prototype and just do tape around the paperclip heads. That might be fine. In that case, I can bend it like that. So tape around there. Long, spindly part. Yeah, so it would look like that. Taped on there. Spindly elbow. Do I want to go ahead and wrap this around like a spring form kind of thing? Because, I mean, here I'm planning on decoupling it with the paper, but it probably couldn't hurt to also try to make this leg a little bit more decoupled. How much of this do I need to... so I should get the toothbrush out, too. Which ones are we using? Okay, these are the other 2 that I got the other day. They both have straight bristles. They both kind of have a wavy pattern. They both have about the same thickness of head. I guess the only difference I can see that really matters is that this one's clear and this one's opaque. Let's try using these. This also is an opportunity to try a different brand and see if we can just cut through them with wire cutters instead of like a hacksaw or giant shears. Ow. Max Radio Repair asks, are the paper clips in such proximity to the coil adversely affecting it? Not as far as I can tell, and not that I would expect. That's just very little metal. Like, it's not like a Faraday cage, it's just a little bit of metal. Like, it's not, and like we're working with magnetic fields here, and this is, it's like not any appreciable amount of magnetic shielding I would expect. All right, so 3 more toothbrushes. Choppers. Hey, this might do an all right job. Oh yeah, that's soft. That works. I'll go in with the side cutters to clean that up. So this one, all the bristles are pointing the same direction. They're not all level, but I don't think that matters so much. I'm probably going to mount it kind of like this, so that it presses that way, or I guess like that might be fine too. This just seems a little more stable, but this is like more stable as like it won't fall over. This is more stable as in it'll pull in the consistent direction. So I think I probably want to aim for that, but like the difference between the two is just bending the paperclip a little. So it's not a big deal to experiment with that. Alright. Then I'm going to use the short fold as the inside part. I think I do want to curl this around something just to give this less stiffness. Oh, Tuco, stay out of here. A little screwdriver, maybe? Okay, and I'm trying to make these pretty much the same. Oh, totally. Mike's Radio Repair says that in my world, RF, it doesn't take much to screw up things and change resonance frequencies. Yeah, so just to be clear, we're not doing this with resonance. That's how the real Wacom and Huion pens work, but to make this simpler for a tutorial, I'm just like driving it directly with the signal rather than using resonance, which is a lot less efficient, but easier to get right and harder to get wrong. Alright, so got a few turns, and then I'm going to leave that for adjustment. Alex is waving at Tuco. Yeah, where is he? Got a little carried away with that one. The very end, I don't want that to be actually curly. I'm like kind of curling it straight around the screwdriver and then loosening it a bit so that I get wider curls like that. Mike 30 Repair says, I see you perfected toothbrush decapitation. Well, I've gotten better at it now. Yeah, the big wire cutter does a nice job. Alright, I think those are roughly the same. And then roughly they all have an ability to hang out among some tape in the middle. I can like thread tape between there. And then this will come out and meet with a brush foot, like that. So each of these needs a little curly Q that I can melt into the plastic. Before I make the curly Q, I'm going to strip off some insulation so that I can just apply soldering iron to this. So I'm going to strip off about 1 centimeter. Much easier when the paperclip is mostly straight. Ooh, lovely snowy night from the East Coast, says Paul on the YouTube chat. That's cool. I miss snow sometimes. Okay, so those are all removed. Okay, and now the orientation here is going to have to be I think I want to go in and then make at least one L turn. But maybe like a full U-turn would be better. Like a little foot like that. Not much focus there, is there? Let's do a couple of those. This is where it's handy to have multiple pairs of pliers. So the little foot here is just to give something for the plastic to kind of flow all around to make a good bond between the foot and the wire. So just 2 little hooks, about to be 3. This handle has slid down. Oh no. I just was twisting this and I guess I had a nick where I cut the end off and it just totally broke. Alright, let's start that one over again. Okay. So that goes up and then around the screwdriver. focus. So close. Okay, I'm back up to the point right before the bend that messed it up. Okay, could have left a little more wire that time. I think that would work. All right, then each of those, might as well bend this a little before I actually add that. So I think it'll end up being kind of like that. But I'm going to try to put that in relatively straight. So put that in straight, and then the vibe motor will go on the outside edge right there, I think. I think I'm going to put the toothbrush in the stick vise. Not by the bristles. Okay, so I've got the place where the neck used to be on my side. Alright, so I'm just going to try to get this roughly in a centered looking spot, and then we can adjust it with the paper clip later. So I'm just touching the wire with the soldering iron. If you wanted to touch the plastic with the soldering iron, you would want to have better ventilation and less of a soldering iron tip you care about, because that really messes up your soldering iron tip and will melt a lot of plastic. But here I'm just heating up the wire and then pressing the wire in. I'm trying to help it form a little puddle of plastic right behind the wire by holding it a little extra without pushing it. And I'm going to try taking the heat off. And it looks like the plastic there is still kind of molten. I'm going to try pushing it in with the pliers. I don't know if that's actually going to help. It's hard to tell that that actually worked. That doesn't look like it's quite as strong as it was on the other toothbrush head. So I'm tempted to just add a little more heat using the same strategy. In fact, maybe add some solder to help the heat conduct into the wire. This is also just a bit of an aberration because these clips are tinned, which is not common. Yeah, that's really not so great. I might have to either backfill this with glue or hit it with a sacrificial soldering iron tip like I did with the other one. Well, I'm going to warm up the sacrificial tip. I think that's probably the right solution just to make progress with this. I don't like this, but I think it'll work. I just think it's kind of a messy solution, and I don't really like having to include this in the list of steps. So I'm looking for a better way to do this, but I think it'll work. Let's load a second one up over here. Like that. Oh, yeah. Yeah, that's a good question. Star Manatee in YouTube chat asks if the toothbrush bots can do anything or if they just jiggle around. And yeah, I mean, they do jiggle around, but the goal here is for it to do other things. One of those things is to have a pen attached so that you can see the jiggling. The other goal here is for it to actually have closed loop control over the pattern so that you can have it actually draw particular images rather than just random stuff. Random stuff is nice too, but this was an idea that I wanted to explore to see how much intentionality you could get out of a bot like this. And I think the idea is, I think it'll actually be fairly detailed once I get this thing working, but it's taking a lot of debugging to get there. Okay, so there I am kind of filling in over where the wire was on that toothbrush head. See if I can get a better image of the second one here. I don't need solder because that won't even help because it won't even stick to the soldering iron tip anymore. Alright, so this time I'm just going to put the iron right into the middle of that little U that we bent in the wire. Alright, so similar. Let that cool. And then, do I have another vise handy? Yeah, it's an interesting question. Can toothbrush bots do anything? Which is kind of the question I'm asking myself with this project. That my hypothesis is, well, yes, of course they can do things. And actually, since starting this, some people have sent me examples. Like somebody made a bristle bot that could steer, and I think they had a fan on it so it could blow out candles, which seemed pretty neat. And so, I mean, part of this is, well, yeah, they can do things, but can they draw? Can they draw images that actually approach some intentional result? That's what I'm going for. Yeah, and kind of a balance between control and chaos is the goal. Like, for example, imagine that this thing was fully capable of perfectly reproducing a drawing. You could probably just make it go faster and then watch how it messes up, and I would find the artifacts interesting. Like, that's kind of the directionality that I'm interested in. Like glitch art, but for physical processes. Like, you do that with 3D printing, and it's interesting sometimes, but you have these structural constraints so that the result doesn't really hold together. And like, I guess you could do that with plotters, but usually then the result would be missed steps, and so you'd end up with like offset errors, which could be interesting. But I think what's nice about this is the result is still trying to converge to the right thing. Like, I think that's the fundamental difference with the closed loop versus open loop process. Like, with a glitch in a closed loop process, you're just watching it continue unaware of the glitch. But here, it's like you're watching it respond to glitches as they happen. And this whole thing is basically made of glitches. It's like this draw is using only glitches. I've got to have a disclaimer anytime I do this that this will mess up your soldering iron tip, this will be bad for your health, this will be bad for everything. Just like, don't do it unless you're in a well-ventilated environment and you don't have a soldering iron tip on your iron that you care about. So like here, I'm in a really drafty room with lots of space, and I'm not doing very much of this. And I open the window when I am, and I use a soldering iron tip that I don't otherwise care about. But this will very quickly destroy your soldering iron tip using it on plastic. So I recommend having a separate tip that you use for this kind of thing. All right, let's examine the one that's had the most time to cool over here. Seems good so far. I think it's going to be shaped something kind of like that, with the tube in the middle, and then the brush kind of jabbing away at the edge there. We might end up tweaking that to see what the vibration modes actually are, but I think that's going to be all right. I think what we want here is for the motor to be in this plane, so that you have a lot of motion like this that ends up, like the left to right or right to left won't really have much of an effect because the bristles are not angled in that direction. But I don't know. It seems like, I mean, this is like the angle I've been using before, is kind of like this motion more. I mean, part of this is moot because like the vibration modes are also intertangled, that you can't really keep them separate. But I'm just imagining that maybe mounting the motor this way instead of this way will get less of the vibrations into the other legs. So maybe that's something else to try. Cool, got another one like that. I'm not gonna give that one a lot of stress just yet because we just did that one, but yeah, that looks like they're all basically good. I think the next step is to take apart the old robot so we can use its pieces. I realize I haven't even really showed you this thing skittering around. I mean, it's not that interesting. It moves very slowly. It's very temperamental. I'm just mostly annoyed trying to tune it and want the brushes to be pointing the other direction. So as for disassembling this, I'm just going to take off as much of the shape block as I can first. Yeah. Star Manatee asks if we could make these robots clean. Yeah, right? They'd be the least effective cleaners. Stuff gets so sticky when it's hot. I think I want to just try to separate the motor from the rest of this. I don't really care whether I get all the stuff off the motor right now. Just remember, it's okay to just take plastic off, even if I can't get the whole thing off. Alright, one motor freed. More heat, Captain. That feeling when you hear your friend open a beer and think, oh man, I could use a beer, and then remember you have one. Sometimes it's hot. I know, right? I just hit it with a heat gun. Oh, nice. Nice to see you, Sarah, and congrats on finishing some video editing. I should do some more of that. I feel like I've got so much footage that is still in my video editing pile that I don't quite know what to do with right now. Oh yeah, Paul Moffat mentions they saw a Hackaday article about using 3D printer stringing to kind of create bristly structures. Yeah, that would be great, right? That would definitely be something to experiment with if we go back to 3D printing for this bot, which is probably on the table. I wanted to try making a non-3D printed version of the bot, but it'd be nice to have a 3D printed version also. One thing that's nice about the non-printed version is that it's very adjustable, and so I can maybe use this to get a better idea of what parameters matter before having to explicitly design all the adjustment mechanisms that I'll need later. This kind of gives me a bunch of adjustment just because the thing is made out of malleable materials. Oh, and then Paul Emesta in YouTube chat says perhaps a rubber eraser as a foot. We tried using some stuff that's a little bit sticky. I tried, actually, I guess I don't know what kind of eraser you were thinking of, but I tried using like kneaded rubber, like artist's eraser stuff as a foot, and I got the robot into a bunch of states where it was just like violently wiggling around without moving at all because there was so much friction. And then I tried augmenting that with some other strategies, like what if I was getting tons of friction from the feet, but then counteract that by always using at least 2 motors? And so I tried that a bit, and that was okay, but I kind of gave up on that. Yeah, I don't know. I mean, so there could be other foot options. We've been over a few different foot options, and I think so far the thing that I really like about the brushes is that having many different contact points means that none of the individual contact points are actually that critical as far as I can tell. So it's less about having to optimize one little microscopic area to be perfect and more about just in aggregate having stuff right, which seems nicer for a lot of reasons. More likely to keep working, easier to get working for other people. Alright, another free little motor, and heat gun is still whirring away back there. Let's hit the last area with the heat gun. Oh, interesting. Paul was thinking about something like a pencil eraser that you could like skewer on the paperclip. That would be neat. That would be a neat, so we were talking a little earlier about like vibration absorption strategies, and that would be kind of a neat way of like having a vibration absorbing coupler, just having a rubber eraser that you skewer with multiple paper clips. This is a terrible idea, but I just momentarily thought, okay, let's, while we're doing weird things to the toothbrushes, put the toothbrush head on the drill press, and then drill a hole in the toothbrush head that's the same diameter, or maybe a little smaller diameter than one of those pencil erasers, and then press fit the pencil eraser, and then bury a piece of wire in the pencil eraser. Ah man, I keep incorporating what I can only assume are charred remains of my thumb flesh in this plastic. It kind of has that property that hot glue has, where it's hot and it wants to stick to your skin. I think it's less hot than hot glue, I think, usually, but very sticky. I don't need to get all the plastic off the motor, but I'm going to take some of it off. The plastic doesn't stick to the... There's like an adhesive sticker on the back of the motor, and then there's a backing sticker on the adhesive backing, and I guess it's not surprising that the anti-adhesive sticking backing is not sticking to the plastic, but there's that. It sticks to everything else pretty well. Alright. So now the vibration motors are free. we're just trying to recycle the parts of this robot that I want to use in the next robot right now. So I freed the vibration motors, because the vibration motors themselves are like not super cheap. They're like $2 about, so it'd be nice to keep them, of course, and I don't want to have to rewire everything. So I want to free this paper tube thing. I did some of this installation in a weird order. If I were to just push this out, it would mess up a bunch of the wiring. So I'd like to not do that. I think I'm just gonna have to like scrape off bits of this with the heat gun first to do this. Like, I could certainly salvage individual parts more easily, but I'm trying to keep the wiring harness intact. Here I'm hitting Scotch tape with the heat gun. I know that's not gonna go too well. If we do have to redo the wiring, it's not that bad. Like, I've got plenty of extra on, like, range on this leash. Solid core silicone wire. Oh, for the foot. Maybe. I don't know if I want to use copper wire at all for the feet, though, because I think it wouldn't have enough springiness. It would just deform and stay deformed. This whole process of trying to remove all the plastic I can is certainly a good way of giving the object a nice sleek exterior in the process. I think I want to just get all the plastic off of around this kind of triangular structure so that I can either remove it or cut it apart. That wincing is just burns, don't worry. Oh no, I'm getting hair in my plastic, turning it into a high-tech biocomposite. Oh man, I just accidentally hit the bristle with the heat gun a little bit, and it does not take much to distort the brushes. See that? Curled up a little. I'm gonna start cutting pieces off of this soon. But I want to get most of this off. Like, I can expose the underlying metal this way, And then I'm going to cut the underlying metal so that it's much weaker at least, and then get enough of this off that I can at least continue with this prototyping stuff. This paper tube is not especially happy with me right now. Also, my fingers are not happy with me. Fingers are like, what the fuck? I don't know if I'll have to retrain Touch ID. That was hot. That was just hot and slippery. How did that happen? I think I managed to heat up some of the Scotch tape under there, because it's taken a bit of an impression of some of the other layers. Okay, and with just that much heating, this actually gets really soft and doesn't stick especially well to the tube. So once I've freed up all the wiring I care to free up, I'm going to heat this again, and then I should be able to actually get it all apart. But first step is to take the armature here apart carefully. Robot Disassembly Club. This long coily cord thing is pretty neat. Okay. So, where are the wires I have to care about? There's motor wires that are all coming up onto this side. There's a couple of crisscrossing bits. I need to carefully cut this heat shrink with a knife. This knife is so sharp, it's really nice. Okay, that heat shrink is slit. Oh, yeah. One more. I do really appreciate the three-way symmetry on this robot. There's a little bit of three-way symmetry in Tuco Flyer, but it's got a lot more four-way symmetry. And some two-way. Okay, so with these little collars, the wires for the motors are now freed from the structure. They're just being held on by the plastic now. Some of these more than others. Yanking out the heat shrink. Alright, so I'm going to warm up the plastic and then pull those wires up until they reach the tape here, and that'll free it from this whole structure. And then I think I can just pull the whole tube out and then just keep the rest of this intact. Let's do that. Paul says, Mike says, lol, a fleshy brush pot. Yeah, right. And then Paul says, for anti-vibration machine mounts, it's common to just compress a rubber washer or shim between the surfaces. Segments of a rubber band or a pad of hot glue between mating parts, maybe? Yeah, that's a good question. I've been thinking about something that involves like wrapping a rubber band. Like if the next strategy turns out to still not quite be good enough, we could maybe like wrap a rubber band around the top and then put the paper clips on there and then another layer of rubber bands or something. That's just kind of straddling the boundary between like enough isolation and not enough like structure. I don't know that that would be strong enough, but let's definitely think about that still. There's still a little bit more heat shrink there. Okay, that one is totally free. Well, pretty much. Yeah, no, that one's totally free. And this one is close. There we go. And then this one. Feels like maybe prototyping with Kapton tape is a good way to do if I'm gonna, or way to go if I'm gonna be using a heat gun all over this thing. Anyway, it's really close to being able to take apart now. I think I just need to heat it around this triangle. Try to without completely destroying the tape around that center tube, and then just carefully pull the whole thing out. Like that. I think that's common. Oh yeah, this is how you do rework. They don't call it a rework gun for nothing. Yeah. Alright, let's clean this up a little. Man, this looks so much like a old style radio antenna coil now, with the shmoo on it and everything. Decrease the shmoo level slightly. Yeah, single layer coil wrapped in radio shmoo. Alright. Cool, well that's the nervous system out of our robot. We have now removed only the robot's nerves. And its hand, I guess, if that's what the tube is. I'm gonna consolidate the thermal qualities of my mess over here slightly. Oh yeah, that's interesting. That's a really good insight from Ian. So Ian says, this might be a bit of a distraction from the current tasks, but I just went back and looked at earlier streams with the NinjaFlex bot version, and it struck me how differently a rigid version like that works. And I agree with what you said on the second video at 352.10 about how it probably being the pen that ratchets across the page in that setup, where the brushes are just minimizing friction at the corners. I hadn't appreciated how different the mode of operation is that you're trying to optimize in the new bot design. Yeah, that's really interesting. I guess I hadn't appreciated how different it was either. Since I guess I keep going back and forth on what that was. Like when I was first looking at that, I was like, oh yeah, it's the pen nib ratcheting, whatever. And now I'm like, oh, how could that possibly work? But that's mostly because I've been trying to replicate that mode of operation in other bots and failing and trying other things. But I didn't actually do like high-speed photography from that version of the bot. So that might be one thing we could try going back and doing. Is high-speed photography. Oh, interesting. Star Manatee says, what's the proper way to solder plastic? Well, it depends on what you're trying to do, but yeah, like, soldering plastic isn't really a thing. Like, that's, like, using a soldering iron to weld plastic is, like, a thing you can do, but it's like an off-label use. But actual plastic welding is a thing you can do that, yeah, like one method I've seen that actually works surprisingly well is to just take a high-speed DC motor and then somehow couple your stick of plastic onto the end of that and then just like stick that into the crevice you're trying to weld. I just got lost talking and then didn't actually do anything with this plastic while it was hot, and now it's cold again. I just hit the brush with the hot air again. I'm glad this is not the brush that I care that much about, but I'd like to not break these too much. It's not too bad. Like, it basically just makes the brush look really worn on that edge and messes up part of it. It doesn't seem to make, like, if I did accidentally hit the brush that I cared about using with hot air, it wouldn't totally ruin it. It would just mess it up a little bit. Alright, I think this one goes into the idea graveyard / parts to reuse. That heat gun was mostly cold by the time I hit that because I had to turn the power off already. Yeah, totally. Ian says high speed, and that would be really interesting. And I think both of the approaches, the brush pushed and tip ratcheted, are possible though, and would probably give distinctly different aesthetics on the drawing. That's an interesting insight. I think you're probably right about that. Okay, I'm gonna put this aside, and what's next? There's my delightfully sharp knife right over there where I could have put my hand. And there's a beer on a completely different place. So here's my bot nervous system. Jeez, I still kind of want to clean this up slightly. There, at least get it all into one lump. Okay, so let's put the plastic kit aside here. So we've got the coil and wiring harness in the middle, generously named. So these are the components of our bot, really, the active components. This leash goes off to a breadboard on a Raspberry Pi with some transistors. This coil transmits a carrier signal to the tablet, which we use mostly for position. And then these are the actual vibration motors here. So I think attaching them somewhat close to the top might actually be good. Let's see, how much do we want to actually be able to bend that? Something like that, maybe. So we've got basically a spring in the middle, and then an anchor. So I think in practice it would end up being kind of like this. And this part would be angled slightly out. Maybe even more out than that. I actually don't know what the optimal angle for that is. For an individual bristle, the angle is probably closer to like 35 or 30 or 45 degrees for it to be optimal. But for the entire brush, more angle I think would make more of the individual bristles efficient at pushing it, but means that fewer bristles would be in contact. So I don't know. But thank goodness that's adjustable, right? So I was thinking about whether it would be better to do the next like shape lock part or the taping first. I think what I want to do is bend these all into roughly the right shape. So I think this is the shape we're aiming for right now. Get them all into this shape, then plastic to attach the vibe motors without damaging the bristles with the heat gun, and then tape it all onto the tube. And then I think this version of the bot's done. I think this doesn't need much more. Alright, that's close enough. Let's heat up some more plastic and attach some motors to these brushes. Interesting. Sam says you may consider also shaping the bristle surface. I've considered it. It's one of those things that seems like it would be extremely fiddly, and I'd like to avoid doing that if at all possible. So I'm going to put that off, but it's a thing to consider later if we end up needing the bristles to be more even or to have a particular angle, sure. Alright, let's heat up a bunch of this now. If you can think of a good way to trim the bristle surface, I'm all ears. But I've tried trimming bristles like that with like side cutters and scissors and stuff, and anything where you can only get a small number of bristles in there at the same time, it's like you're going in there and like having to adjust individual bristles to even them out, and it's just very tedious. So it's one of those things where like, well, obviously it could be done, but it's just so much additional tedium that I would like to just find ways to avoid the whole process if that's possible. Not just for me, clearly, but like for the people I'm designing this project for, people who would want to build this. I assume those people exist. That's kind of why I'm doing this, but you know, that might not actually be real. Oh yeah, a hand Dremel, something like that might work. I could see a Dremel just wanting to like rip the bristles entirely out, but maybe that would work if you're careful, yeah. Yeah, maybe, I can't think of anything better than a Dremel cutoff wheel, honestly. And that's not great, but it's like better than scissors. Oh, a beard trimmer. Oh. Oh yeah, I've got like hair clippers. Oh, interesting. That's a very rapid approach. Like, it would be really fast. It's really fast to screw up with it, but really fast to do it right if you happen to do it right. So, that's interesting. This lump of plastic has gotten kind of sad and, like, a little bit darkened. I wonder how much of that is dead skin cells. Whew. Oh, this stuff is looking so sad. Oh, you know, maybe it's absorbing some of the grease that I got on my hand from fixing the camera. I do have more of this stuff. I don't have to infinitely recycle it, but it is pretty easy to recycle. And this waffly pad is actually kind of great for this. I grabbed it because it was just what I had in the kitchen, but it's actually really good for kind of cutting into the surface a little bit. Thomas says, I thought that was the cat hair reinforcement fibers. I think you might be right. This is like the opposite of a pie crust where you have to keep it cold so the butter doesn't melt. You ever watch people work on like rolling candy? Like, I saw somebody recently, this was like not in person but online, and they had a copper table that they could hook up to either hot or cold water to either keep the candy hot while they worked it or to cool it down quickly. That seemed pretty cool. Stuff, heat travels so slowly through this stuff. Anyway, I've got plenty of it warm right now. I think since I managed to heat it all up, I'm just going to try to spread it out a little. I'll make some snakes. Alright, and I'll take this one and divide it into 3 roughly equally sized balls to use for mounting the 3 motors. Oh man, the waffle also holds balls in place, which that's pretty great. Bummy worms. Alright, I'm gonna keep some of these over here. Yeah, they do look a little bit turdular, don't they? Oh. Oh, yeah. I think I might have seen one of those videos. Thanks for reminding me. Paul Moffat said Lofty Pursuits has a YouTube channel where they hand make hard candy, and they use a massive ancient water-cooled steel table. That sounds cool. I'm going to have to check that out. That might have been what I was thinking about. Alright, so now that I've got the extra plastic put away in little curly cues, I'm going to heat these up. I only really need to heat one of these because I'm going to have to heat them each time I do this, so let's focus on heating one of them up. I'm going to get it pretty good and hot because I want this to bond pretty well to the stuff around it, and it's going to lose a lot of heat as I prepare it. I don't want to overheat it. It starts to decompose and smell bad and release toxic fumes if you overheat it, which is of course not so fun. And then, whew, yeah, that is maybe a little, that is really hot, and it sticks to my desk and my fingers and everything. And let's just put it on. Whew. Sorry if that was off camera. I'm trying not to burn my fingers while I build this. I'll try to do better on the next one. Yeah, so I was trying to do a pretty good job with molding it all the way around the Vibe motor. Keeping the motor right next to that joint where it's strongest. And then I think I just want to leave this alone to cool. If I need to, I can clean this up a little with the heat gun. I just have to be really careful about the bristles and maybe even put some aluminum tape over the area to keep the bristles from getting impacted at all. Also just smoothing this around, smoothing this out a little bit so the texture isn't entirely my fingerprints. All right, one down. Two more kind of like that, except maybe with more finesse. So maybe there's two more I can do. That could be the next one. If it starts to bubble, it's too hot. Go back a few degrees. Yeah, don't do that. Getting it on both sides is the hardest part there. You can easily just like plop that ball of stuff down on one side, but getting it onto the inside also. I should probably maybe divide the balls into smaller pieces and just have one on each of two fingers that I don't mind burning. I run my finger under some cold water while this cools down. Be right back. Oh, that gimbal doesn't sound happy. Let's point that back at the actual cat. Do I want to open game bar? No. And there's a checkbox to say this is a game. Well, is it? And I don't know if it's talking about OBS or the Tuco Flyer controller. Anyway, the driver still seems to work despite the UI having its own thing to do. Came back to set the orientation of this motor as it cools. Okay, one more of those, hopefully with less pain. Oh wow, this other dot is still warm. The one that I haven't heated up in a while. I think that last one I just got too hot. It didn't need to be that hot. Alright, so one more, kind of ready to go. That was better. Not entirely without burning my fingers, but pretty close. I don't know about that backside. This one seems to be especially light on backside plastic. You know, at the risk of burning myself yet more, I might heat up 3 more little balls of plastic to put on the opposite side. These are looking good so far. Kind of. I don't know, I don't want to put anything more on these. This is the only one that looks a little light, and I think it'll be alright. I'm just going to put maybe... You know what? I'm not going to worry about it. I've got enough of that. Alright, geez, this mess here is a bit of a problem. I need to get some of this stuff off of these wires. Back to the heat gun for a little bit. Just gotta get this stuff off the wire, because otherwise it will cause the wire to break as I manipulate it. It's way stiffer than the wire. One more. Hot. At least I'm burning different fingers. Paul says good art always asks for a piece of yourself. This is true, although unfortunately bad art does as well. Alright, I can put the plastic aside again. So, what kind of tape do I want to use for this? I've been using plain old sticky tape, so I might just continue this. It feels like duct tape might be slightly better, but I think just in the interest of reducing the number of parts, let's stay with this for a bit. So each of these want to go close to the top of this tube, 120 degrees apart. And if I'm going to do it this way, I think I am going to try to bend these up first, and have some tape to set that direction. Oh, this tape, I really don't like it. This is not good tape. I'm definitely going to use different tape if I can next time. I don't know, I mean this tape is so universal, it's just not really good. So I'm going to try to tape these on one at a time, so I don't have to try to fix them all simultaneously. And then I'll run some tape around all of them to reinforce it. So for that, I'm going to just grab and go like in there and then out. And the first one can go pretty much anywhere. Don't cut off any ears. Oh geez, yeah. Not quite there yet. Okay. I'm going to try to get these angled right, but it is maybe easier to adjust the tape at this stage than to make massive adjustments to the wire. That's too far. That's a starting point. I think that's all it is. Let's put the next one on, and then we can just start adjusting them more, maybe. It's just barely looking alright, but I need to put some more tape on there before I can really bend it into any kind of correct position. So, get that out of the way. This is looking kind of silly. Some of these are too far up. Maybe just that one. This tape is so bad. It'd be easier to tightly wind this if there wasn't so much stuff in the way. Like, I don't want this to be that tight of a joint, but it does need to be adjustable and kind of hold its position. Alright, adjustment time. So trying to get these all equally spaced, angled slightly inward, and just angled properly. The proper angle is, I think, this pointed inward 30 to 45 degrees, maybe like 20 to 45 degrees or so, I don't know. That can be arbitrarily close to the middle. If it's touching, I think that just increases the vibration conduction a little bit, but it's not terrible. So this is like the one correct leg so far. We have wire, which can just hang out wherever. We have structural wire, which acts like kind of a spring. We have vibration motor. We have the brush angled in toward the nib of the pen, and then the spiral that holds the pen, the coil that transmits the position. And the mount here is really not that sturdy, but given that we don't want to transmit vibration, maybe that's fine. Kind of like that. I think this certainly needs a lot more tweaking, but that's getting closer. Okay, that's basically the idea I had in mind. It's pretty much ready to test. So we have brushes angled like this, vibrating motors, and somewhat decoupled from each other. This paper is kind of messy. Let me see what I have that's a little bit less messy. Well, this is just differently messy. Okay. 3 volts. Raspberry Pi is awake. And let's at least, we don't have to have the pen opened, but I at least want a pen in there so that there's some weight and something dragging on the paper a little. And I think this is still set up to, yeah, to just sit in, it's just going to sit in one mode for like 10 seconds. Okay, they need aiming. That brush is working all right. It's twisting a little. They all need a little more contact there. I mean, so this is basically working so far, but I need to adjust the brushes before I can really see much more. So a little further out, further down, and more angle. Oh no, these wires are definitely going to get tangled eventually if I don't manicure them somehow. I'm just going to kind of squish the wires into the area around the paper clip for now. Alright, there's the bot. Pen. Let's give it a nib. Sits pretty well in the nib. It's also sitting pretty well in the 3 brushes. Alright, that's the bottom brush. I think that's this brush. It's not doing much. What about angling this more? That brush is doing something. That's working alright. That was just working alright. We've got maybe 2 of 3-ish. That's not doing much. I think that needs more angle. I just went back and forth a couple times between a couple of these feet working really well and not working at all. I'm not quite sure what changed. Yeah, I wonder if this is about the length of the bristles. Yeah, maybe trimming the bristles would be a good next step. I could also just revert back to a faster software timing so that we could see all the vectors at the same time. Well, these are not amazingly reliable, so I don't know if that would help. Just turning up the voltage a little bit to see if that would help at all. I don't think it does. Ah, yeah. Paul in YouTube chat says that the process of mapping vibrations to geometry is reminding me a little of the sound fields from your Wiggleport project. Yeah, maybe there's some love of vibration modes underlying all that, and maybe the two projects could actually come back together at some point. Oh yeah, Gravity Road says, I know I've been playing too much Zelda because as I watch you handle the hot shapes, my mind keeps thinking, equip heat-resistant armor. Wouldn't that be great? I was thinking about gloves or something. I don't know if I have anything that would be heat-resistant that wouldn't just stick to it all. You know, I wonder if this has to do with the orientation of the vibe motors. Like, maybe I was wrong about the twisting it this direction, and maybe if I rotated it 90 degrees so that it's back perpendicular or parallel with the drawing direction, that would work. It is purring. Kind of works. It's just not very many of the bristles are making good contact, and it's still very sensitive to the center of gravity. I'm just going to try tweaking the angles some more. I wonder if this needs more weight, actually. You know, I'm like just trying to feel this a little bit, and I tried pressing against the table, and then I noticed that it bounces around a lot less and actually moves better. I don't know, actually, maybe that was less about the weight and more about pressing, changing the angle slightly. Ah. Scoot. That's nice. I think I'm gonna have this switch a little faster because right now it's kind of hard to tell because I'm running out of space before it actually switches mode. Maybe just 1 second. And it'll just hop between modes every second with these settings. Oh yeah, Keith said we're trying to turn 2 motors on and leave 1 off work. Yeah, we've actually been exploring a few different ways of doing that, and I don't know actually what I have. Like the current code right now I think is only turning 1 motor on at a time, or at least that's what it should be. But I think what's checked in right now is actually using both single and dual motor combinations. Look at that, we have 3 different modes, it's just one of them kind of sucks. Oh, it won't change if it's not on the tablet, because the control loop just stops running. Now I'm just holding it above the tablet, feeling how it vibrates. fuss with the parameters. I kind of want to just see the algorithm running normally now for a little while. So we can change the acceleration and modes. Yeah, let's revert all that. And I think I need to change. I'm wondering if I can still use this a little bit. The PWM decay algorithm really needs work, but I think this might be better than nothing. Let's try it. Yeah, the PWM adaptation algorithm is just all over the place. Let's turn that back off. The process of turning vibration into motion is very unreliable right now. So just to quickly explain some of what's going on in this visual, these kind of crosshairs show the current location, the line shows where it's been. These vectors right around the current location show all of the places where it thinks it might be able to go just based on the recent vectors it's been getting for particular motors. So the ability for this thing to actually navigate around an image is kind of dependent on having sort of a star-shaped pattern of vectors around the current location. So having some in all the directions. And if you ever have a lopsided cluster of vectors there, it's not going to be able to draw very well. So that's kind of where we're still at most of the time. You can see we're occasionally getting some good vectors, but the motion is really not very reliable. And of course, if you look at it, you can see a lot where it just like is ramping up the motors and not getting anywhere, and then all of a sudden it moves. I'm sure this Kapton tape on this side is not really helping. Let me see if I can get that off. So at least some of those brushes are like spinning a lot more than they're actually moving. I'm also noticing that they don't seem to be supporting the weight very much. It looks like what's going on actually is that the little center spiral is actually winding somewhat tightly around the pen, and that this is actually supporting a lot of the weight now. So what if I just rotate this? What happens? So that releases some of the tension in that spring. But now we've mostly just got a lot of wiggling without a lot of moving. Like there still isn't enough weight, maybe? Is there something I can do to quickly test that? Just like put a plastic donut on top or something. Ian says seems like a debugging mode tied to a joystick would be helpful. Just like a few buttons that turn on each motor, maybe. Let's heat up some plastic and put the plastic I have on top as a weight. Mako MK says, how did you end up with that brush and motor configuration? It feels like it should spin the thing mostly. It would if we were using the previous brush heads, which were angled, but this time I'm not relying on the angle of the bristles in the head, but rather I'm angling the whole brush head. We also still haven't really tried trimming the bristles, which is kind of still on the table. I guess that is one thing the weight helps, is it helps more bristles actually make contact. You know what else might help more bristles make contact? This is terrible and I probably shouldn't do it, but sitting it down on the page right here and just hitting the bristles with the heat gun very briefly. I don't think I should do that because it's pretty risky, but that might be an option. Maybe put 2 of these on there. I guess what Ian's describing might just be like a separate program where you press buttons and that turns on the motor. I agree that would be useful, it just hasn't seemed quite useful enough for me to spend the time making it. Yeah, interesting. Paul in YouTube chat suggests that thinking in terms of sound fields might help you model better how this stuff behaves. Yeah, I have 2 opinions on that. One is like, that's really cool and let's definitely do that. The other is, that sounds way more complicated than what I was trying to get at with this project. I think they're both pretty valid though. Like, I would love to experiment with that, but I also, I think that there exists a simple robot that does this like wiggly drawing job, and I'm trying to see if I can find that and document it. But yeah, maybe the complicated analysis helps you find a simple robot, and that's part of how this has to work. That's already a good bit heavier. I'm a little worried that's going to be lopsided right now. But I can always heat that up more and mess with it. I'll put some centered over here. Sheesh, I should let this cool before I mess with it too much more. Just because it's going to keep changing otherwise. Oh yeah, and a couple of people have brought up how it should be possible to do this with less than 3 motors. Yeah, I mean, there were a couple of interesting research papers that came up too. Like there was one that was using magnetic fields that oscillate and then cause a small robot to vibrate. And they were actually going pretty far with just controlling the robot in 2 dimensions using only a 1-dimensional signal, so that just that magnetic field. And they were using different vibration modes to get different kinds of motion. So that seemed pretty cool. Paul says to add a pen cap. That doesn't quite help me with this particular thing, because the pen actually floats freely from the rest of the robot. So a pen cap might help to weight the pen, but the thing here is I specifically wanted the rest of the robot to have some weight too. Previous versions of the robot body was actually rigidly attached to the pen, but like the NinjaFlex version over here it was, but the current one that's not the case anymore. Okay, well, this thing that I did up here kind of negates what I was trying to do with using the paper to separate the vibration between these, but I'm hoping they're still mostly separate. Let's just see how this works. So we got a pen, it's in there, run the software. No. Alright, what's going on here? Let's go back to the mode where it's alternating between the vibrations. I'm like trying to stare right through this pile of stuff to see the screen. Oh, I've got multi-motor modes on right now. Let's turn that off. Oh, of course the keyboard's in UK mode again. Why? I haven't rebooted it. I haven't killed the X server. I just left it alone and it changed to UK. Okay, and now I can comment out lines. I know someone mentioned what the UK keyboard mapping is for the pound sign is, but then I promptly forgot because I just can't remember stuff like that. I'm generally really bad at remembering anything that's completely arbitrary. Maybe I just need to turn the voltage down. Wow, the behavior is definitely very different now. Okay, I'm tired of fighting the timer. I think you're right. I need some interactive control over this. I don't know if I want to do that this late, but why not? I don't know if I have, I guess there's the Steam controller. So I've got a Steam controller and a dongle. I don't know what this will show up as. I don't know if it's like a standard joystick device or if it's all Bluetooth. Oh, there it is. Steam controller was the first one, 28D. So it's a HID device with keyboardy stuff. Let's just see what EVDev says about it. Oh yeah, Ian suggests keyboard keys. That might be a little bit less dependency laden, perhaps. The Steam controller is acting like it's paired to something. Am I controlling the desktop on my Windows machine right now? The world may never know. Why did we just reconnect? I don't know why we just lost the connection. Aw, cool. Got hosted by Dammit Dave on Twitch chat. Thank you. Well, okay. I don't know why my input on here is... Oh, come on. There we go. I think I just typed that wrong. So this is the machine I was using it with before. I was just curious if it might have been still connected over Bluetooth, because as I move my mouse over this, it's still giving me the clicky response as if I'm moving the mouse pointer. Wireless controllers. Or a function generator. Geez, now you want me to sample that with code, or like have that control the 3 motors somehow? I don't need to make the stream about enumerating all the different ways we can get input into a computer. That's not really the problem at hand. Yeah. I could go through and write some software that would just like scan keyboard input and like actuate this or whatever, but I don't know that I really care right now. I think I might just like call it a night and come back to this when I'm a little fresher. It's a little late for me to be streaming. I just kind of really wanted to try this out. Anyway, I think that this design, even though I'm sure that this looks like it's pretty bad, I'm actually encouraged by it because the problems that I'm seeing are completely manageable. So, I think that a lot of this is just a matter of angling the legs right at this point. I think there's probably enough weight. I'm not totally sure if the motors are better the way they are or angled 90 degrees, but we can fuss with that if we need to. I'm pretty happy with it so far. I'm still happy with the tube thing. So. Siri control, that's terrible. Alright, I think I'm done with this particular peanut gallery. Anyway, in all seriousness, no, it's really been nice hanging out, and I appreciate having some company working on this stuff and working on it for people out there on the internet to hopefully join in the fun with and replicate and enjoy, assuming this is actually worth building. You can even actually feel the difference in how the brushes make contact just from the top like this. It's interesting. Yeah, even just kind of fussing it with my hand like that could be helpful. But yeah, some debugging software would help. It would be nice to have something that lets you manually go through the modes, but also still measures the vectors and shows me the graph. That would be handy. I mean, I'm already using Pygame for that. Like, I could just add some input to Pygame to take over manual control of the inputs. Just probably not right now. I'm going to come back to it a little bit later. So maybe get a side view of what we've got so far. So there's some good aspects of this. We have a smaller form factor now, so this can get closer to the edge of the tablet without falling off, which is nice. Got that little spiral in the middle to hold the pen, which I think is still mostly working. It's not perfect, but it's better than every alternative I've thought of or that any of you have contributed and I've noticed. So I've liked that so far. And yeah, some more adjustment, some more software. I'll see you folks later. Happy hacking, and special thanks to everyone who contributes by sharing the channel with your friends, or by just hanging out, or by helping out with $1 or $2 a month on Patreon to help me pay the rent and buy cat food. So thanks a lot. I will see you folks next time. See you later. Actually, make sure the stream stops this time.